So for this one, it is an inclined plane with friction, and you have to find the tension and the strain. So the angle is 40 degrees, and you know that the static friction coefficient or the kinetic friction coefficient is 0.25, and you have to find the tension. So you have to start with the free body diagrams. So for the one that's 10, it'd be, you have the tension. And when you're doing free body diagrams for an inclined plane, you always make it at the angle of the inclined plane. And so then you have friction. And then weight is always directly down no matter what angle the box is sitting at. So this is mg. And then the normal force is always perpendicular to the contact. So for this one, the normal force is straight up as opposed to matching with weight. And then and then you have to define your axes. So the x direction is parallel with the slope of that the box is on. And then the y direction is perpendicular to that one. And then for the 20 kilogram box, you just have tension and weight, which is mass times gravity. And then you have to take the coordinate and then flip it so that way it's consistent. So then the x direction and the positive y. So then after you have the free body diagrams, then you have to do the sum of forces in each direction. So for this one, the sum of forces in the x direction equals mass times acceleration. So it would be tension minus friction equals mass times acceleration. And for this one, sum of forces in the x direction equals mass times acceleration. So it would be weight, which is mg, minus tension equals mass times acceleration. So then you need to find the friction for this one. And so since you're given the friction coefficient, you can use that formula of mu k equals the friction over the normal force. So 0.25 equals the friction, which is what you're trying to find, over, and then the normal force for this one, since it's on an inclined plane, you have to divide this into its x and y components. Since this is 40 degrees, this angle right here is also 40 degrees. So then you know that the normal force is always counteracting the weight. So for this one, the normal force opposes the cosine of 40 degrees times the mass times gravity, so 10 times 9.81. So this here is cosine of 40 times 10 times 9.81. And then you solve for friction, which gives you 18.79 newtons. So then now that you have friction, then you can put it back into here. So tension minus 18.79 equals the mass, which is 10. And then you don't know the acceleration, so it's just A. And then for this one, the mass, which is 20 times gravity, 9.81, minus the tension equals mass, which is 20 times acceleration. And then for this one, you can add the equations. So then minus 18. So then once you add the equations, the t's cancel out. So then you're left with 20 times 9.81 minus 18.79 equals 30a when you add the two. And so then you get 177.41 equals 30a. So the acceleration ends up being 5.91 meters per second squared. So that's the acceleration of the whole system. So then you can plug this back into either this equation here or this equation here. So if we put it back into this one, you have tension minus 18.79 equals 10 times the acceleration, which is 5.91. So then tension equals 77.89